Hello everyone. Thank you for another exciting time in our class. What we have here, we're going to, I stated in the last video, the next one we're going to look at is how to calculate the mass. So in this case now, we're going to look at the mass of mass in grams. So that I calculate the mass in grams of 3.4 times 10 raised to the power of 21 atoms of copper. So we have a molar mass of copper to be 63.5 and Avogadro's number to be 6.02 times 10 raised to the power 23. So based on that, like I stated earlier on, what it's important to know that 1 mole, there's a common relationship they have. This is Avogadro's number, and also this other one is their you can say that this one is molar volume if it's a gas, and this other one is molar mass. Sorry, this one is what? Molar mass. So 1 mole is equal to the molar volume. 1 mole is also equal to the molar mass, and 1 mole is equal to Avogadro's number. So so having this in mind, when you look at that now, you try to compare try to find out the area that you need for your calculation. In this our calculation now, since we are looking for the mass, we are giving the molar mass. We know that for this now, molar mass, that is 1 mole. 1 mole is equal to what? Molar mass. What's the molar mass? And again, 1 mole here together, again 1 mole is also equal to what? What else are we looking for? Yes, equal to Avogadro's. Avogadro's number. Avogadro's number is equal to Avogadro's number. So these two information is exactly what we are likely to look at. We're going to use them when we're solving the problem. So now we are given the number of atoms. This is our number of atoms given to us, and we're looking for the mass in grams. Mass in grams. Then the mass in grams, now we know that since 1 mole is this, that means the mass, the molar mass and Avogadro's, they have something in common. That is to say that Avogadro's number is equal to what? Molar mass. Now we're looking for atom. So the number of particles, substance, particle that is in this number of atoms that we have in a copper. In this copper that we don't know the mass is this, and the molar mass of copper is what? 63.5, which has the same number according to Avogadro's, which has the same number. That means what it means that is that Avogadro's is equal to 163.5 gram per mole. That is what from this statement now we're able to find out, since look at it here, mole equal to this and also equal to that. So in this case now, the mass, the Avogadro's number, the number of atoms of this is equal to the gram per mole, that is the molar mass. Then this other one, we have 3 points, we don't know the number of grams we have here, we have 3.4 times 10 raised to the power 21. So in this case, what we do here is that we can calculate when we divide everything we have here. Times 0.4 times 10, 21 all over 1. So if we divide this thing, when we divide, we will have a 0.35 grams of copper. So with this now, once you divide this, you have this, you have it to be 0.35 grams of copper. That is in 3.4 times 10 raised to the power 21 of atoms of copper, you have 0.35 grams of copper. Thank you so much for being a part of this class, and I would like to read your comments. Try and give me a comment, and then like, share, and also subscribe if you have not subscribed. I enjoy reading your comments, and I hope to see you in our next class. Now the next class, now what we're going to be doing is we'll be looking at the how to use this to relate, how we can relate Avogadros with the volume. See, this can go in this way all together too, while all of them circles around the triangle is center. The center of the triangle will have the mole. So what we're going to do in the next class is to look at it, compare it based on the molar volume, according to what Avogadro has already stated, according to Avogadro's law. All right, thank you so much, and hope to see you again.